In section 3.7, we're going to explore the concept of implicit differentiation. So far, we've described functions by expressing one variable explicitly in terms of the other, like y equals x squared, y is in terms of x squared, or y is equal to the square root of 4 minus x squared over x plus 1. Notice y is simply in terms of x. But sometimes we'll get relations or functions that are defined implicitly. For example, x squared plus y squared equals 25, which is the equation of a circle with the center at 0, 0 and the radius of 5. We can still find slopes of tangent lines to this relation using a process called implicit differentiation. So let's go through an example, and hopefully we can explain how implicit differentiation works. So first of all, we are asked to find the derivative of y in terms of x, which means we want to take the derivative of each term in my equation with respect to variable x. So x squared is easy because it's defined in terms of x, so the derivative of x squared is just 2x. Now y squared is defined in terms of y, so this derivative would be really 2y, but this would be the derivative of y in terms of y. So if I multiply it by dy dx, notice that these two dy's would cancel out, and I'm really getting dy dx. So that's kind of the idea when we're doing implicit differentiation, is to do implicit differentiation. Anytime you're taking the derivative of a y term, all you have to do is you have to multiply it by dy dx to make it in terms of variable x. And now the derivative of a constant is 0. So now your goal is to isolate dy dx because that's your derivative. So I'm going to leave the 2y dy dx on the left side of my equation, and I am going to subtract the 2x to the other side, and then I'll divide both sides by 2y, and I'll get negative 2x over 2y. And now if I simplify this, my derivative is negative x over y. So this still represents the equation for the slope of my tangent line, but notice the derivative has both an x and a y variable. To find the slope, and this was my derivative, all I do is I plug in the x coordinate of my point for x and the y coordinate for y, so this ends up being 4/3. So now to find the equation, it's y minus y1 is m, x minus x1, so y minus 3 is going to be 4/3 x minus negative 4. So y minus 3 is going to equal 4/3 x plus 4. And now, depending on how they want you to write your final answer, let's just distribute the 4/3 to get 4/3 x plus 16 over 3. And if I was to add 3 to the other side, I'm really adding 9/3. I want to get a common denominator, so that's going to end up being 25 over 3. And there would be your equation in slope-intercept form. Okay, so here's the process of, or the steps involved for doing implicit differentiation. First of all, you differentiate each term in the equation with respect to variable x. Collect all your dy dx's on one side of the equation, factor out the dy dx, and solve for dy dx. So if you take a look at this example, this is a more complicated relation. Again, you notice I have a product inside here, so I'm going to have to use the product rule, but let's go through this process following the steps on the previous slide. And the first one said take the derivative of both sides of the equation with respect to x. So I'm going to take the derivative of 2x to the 5th, which is going to be 10x to the 4th, plus. Now I'm going to do the product rule with these two terms. So it's going to be the first function. The derivative of y is, in terms of y, would be 1, but then I'd have to times it by dy dx, plus the second function, which is y, times the derivative of the first, which is 4x cubed, plus the derivative of y to the 5th would be 5y to the 4th times dy dx, and this all equals the derivative of 36, which is 0. So if I clean this up a little bit, I get 10x to the 4th plus x to the 4th dy dx plus 4x cubed y plus 5y to the 4th dy dx, and this equals 0. And now if you look on the previous slide, the steps involved were collect all the terms with dy dx on one side. So what I'm going to do is I'm going to keep the x to the fourth dy dx plus my 5y to the fourth dy dx on the left side of the equation. And I'm going to move the 10x to the fourth and the 4x cubed y to the other side. So now my next step says factor out dy dx on the left-hand side. So if I factor out a dy dx, I'm left with dy dx times x to the fourth plus 5y to the fourth. And my right-hand side of my equation hasn't changed. And now finally, in my last step, to get dy dx by itself, you have to divide both sides by the binomial x to the fourth plus 5y to the fourth. So it's going to be negative 10x to the fourth minus 4x cubed y divided by the binomial x to the fourth plus 5y to the fourth. And there would be your derivative. So again, we are done calculus at this first step right here. And then after that, it's just a matter of simplifying. Okay, this question here is very similar. The only difference is there's a minus sign in front of my product rule. So we have to be careful with this one. So again, let's go through this one. So the first step is take the derivative of the first term, which would be 3x squared. And now when I do my product rule, I'm going to lump the negative sign or the subtraction sign with the 4x squared. So when I do the product rule, it's going to be the first function, which is negative 4x squared, times the derivative of y to the fourth, which would be 4y cubed, times dy dx, plus the second function, times the derivative of the first, which would be negative 8x. And then the derivative of 3y would be 3, and then dy dx, and the derivative of 9 is 0. So let's clean this up a little bit. So I get 3x squared, negative 4 times positive 4 is going to be negative 16x squared y cubed dy dx. Negative 8 times 1 is going to be negative 8xy to the fourth plus 3 dy dx. That's all equals 0. And notice I have two terms with the dy dx in them. So again, I could leave them both on the left side, or I can move them over to the other side. It doesn't really matter. I'm going to leave them on the left side, but I'm going to write my positive term first. I'm going to write 3 dy dx minus 16x squared y cubed dy dx. And I'm going to move the negative 8xy to the fourth to the other side, so that becomes positive, and I'll move the 3x squared over, and it becomes negative. So now I'm going to factor out the dy dx. And then I'm going to divide both sides by this binomial to get the dy dx by itself. So therefore, dy dx is going to equal 8xy to the fourth minus 3x squared all over 3 minus 16x squared y cubed, and that would be the final answer. Okay, this is a 2004 AP free response question. And we are just going to look at part A right now. And notice in part A, they're telling you to show that the derivative is this. So again, we take the derivative of the relation implicitly. So it's going to be 2x plus 8y dy dx is going to equal the derivative of 7 is 0. Plus, again, I'm using the product rule. My first term is 3x. The derivative of y would be 1 dy dx plus the second function, which is y, times the derivative of 3x, which is 3. So now I have this equation, so let's just clean this up a little bit. And if you notice, In my final answer here, they have 8y minus 3x on the bottom. So I'm going to bring the 3x dy dx to the left. So I'm going to collect all my dy dx's on the left. So 8y dy dx minus 3x dy dx. And I am going to subtract the 2x to the other side. So notice I have my numerator right here on the right side. So my next step is to factor out the dy dx on the left-hand side. If I do that, I get 8y minus 3x. And that's going to equal 3y minus 2x. And now to get dy dx by itself, we are just going to divide by the binomial 8y dx. There would be the final answer. So again, not that difficult of a situation. Okay, this is from 1997. This was a multiple choice question. I didn't copy the answers down, but let's take a look at this one here. And in this one, they're asking us to find, this is a new notation. This means the second derivative, which is really the derivative of the first derivative. And they want us to evaluate that at the 0.43. So again, the first derivative, we did this one earlier. Oops, the derivative of 25 is 0. And again, if you recall from early on, if we were to do this, it would end up being negative x over y was my first derivative. Okay. Now the notation d squared y over dx squared just means the second derivative. So d squared y over dx squared equals, well, now to take the derivative of this, I have to use the quotient rule. So it's going to be the bottom times the derivative of the top minus the top. The derivative of y would be 1 dy dx. This is all over the denominator squared. So cleaning this up, it's going to be negative y plus x times dy dx all over y squared. And now they want us to evaluate this at the point 4 and 3. So we know dy dx is negative x over y. So what I could do, in place of dy dx, I can put negative x over y. And this ends up being negative y minus x squared over y all over y. And now we can just plug in our values if we want. So this is going to equal, in place of y, I'm putting 3. So it's going to be negative 3 minus, in place of x, it's going to be 4 squared over 3. And this is all over 3 squared. So therefore, I just evaluate this. So I'm going to get negative 3 minus 16 over 3 all over 9, which is negative 3. If I get a common denominator, so I can simplify my numerator, would be negative 9 over 3 minus 16 over 3 over 9, which is negative 25 over 3. And I'm going to multiply by the reciprocal of 9, which is 1/9. So my final reduced answer would be negative 25 over 27. So again, if you're finding d squared y over dx squared, you're just finding the second derivative, which is the derivative of the first derivative. Okay, so there is your assignment on from your Calc 30 book and your 8P textbook. And there are some handout questions, the remaining questions from your handout, which include this one question here, this question here, this question here. And for this one, you can just do parts A and B and that question there. And you could also look at question A here as well. So that's the end of implicit differentiation. So again, give those a try. And if you have any questions, feel free to check the answers or ask me in class.